Hi everyone, welcome back. In this section, we will see few examples of how data analysis can help solve some business problems. Let's look at the first example on how data analysis can help boost market sales. Let's say there's a store owner and he comes to us and says that he has been operating the store for last 1 year and now the sales are pretty stagnant. He needs our help to understand how can he increase the sales. As a data analyst, she first starts asking some relevant questions to help quantify the problem. So she asks that what kind of sales increase are we looking for? The store owner then clarifies that he is looking for at least 10% in next 2 months and about 50% in next year. So now the problem statement is quantified and we know exactly what the store owner's expectation is. Next, the analyst tries to identify what kind of data can we use. So she asks if we can access the invoice level data for last 1 year. So understand the flow here. The owner comes up with a very simple problem statement that they want to increase the sales. As an analyst, she tries to quantify the problem by asking relevant questions and she tries to identify what is the owner's exact expectation. Next, the analyst also tries to identify what kind of data sources are available for the analysis. Right? Once she gets the data, she can do the analysis and come back with results. So she comes back with the result after doing market basket analysis using the invoice data. Before going forward, let's try to understand what is the market basket analysis. So what it does is it tries to understand and analyze the association of different products and tries to understand what are those common set of products that are bought together. Okay, so she presents the results that there are certain set of products in the shop which are not placed together but they are generally bought together by the customers. Something like bread, egg, jam, butter, cheese, right? All the baby related products are bought together, or the energy related drinks are bought together. Cleaning related products are also bought together. Right? So this is a part of strategic product placement which helps the customer access all the required products at the same place. It helps in two ways. One is, since the customer is able to access all the required products at one place, he or she is less likely to miss out on any product and hence buys more. Secondly, when the customer buys one product and sees all the other related products kept nearby, the customer might buy those products also, although it was not originally planned, right? So this also helps boost the sales. So with this strategic placement, we see that the owner was able to achieve the sales growth that he was looking for. Let's look at another example, a little more complex problem where we will see how data analysis can help decide a selling price for a product. Let's say you're working in an e-commerce platform and your manager comes in and says that, we are already selling multiple brands of washing machines on our e-commerce platform, right? These are very high margin products. So we want to launch a co-branded washing machine on our platform. Before going forward, let's try to understand what is a co-branded product. Co-branded product is a new brand of product that is launched on the e-commerce platform. But this brand is completely owned by the e-commerce platform. So they are completely owning the production and the sourcing of the washing machines, and that is why they are eliminating the middlemen and they can get higher margin on the products that they sell on the platform. So the analyst quickly tries to understand the problem and think of way forward. She understands that since we have so much data on our e-commerce platform about what kind of washing machines are preferred, which kind of areas, what kind of washing machines are preferred, what kind of prices are preferred by the customers, what kind of quality are preferred by the customers, what kind of sizes are preferred by the customers. We can use all this data to identify an optimal product and pricing, which we can then sell on an e-commerce platform for the highest profit. Right? The manager then further explains the problem at hand. He says that we need to decide on the pricing for our product so that it generates maximum profit. Right? Remember this point that we want to generate the maximum profit. The end goal can be different. We want to maybe generate maximum revenue. We want to sell maximum number of units. But in this case, let us try to remember that the end goal is maximum profit. He has two options in mind. He says that the washing machine on our platform ranges from 7,000 to 20,000. So we can either price the washing machine at the minimum of the all the washing machines that is sold on our platform, so that maximum number of customers buy it. Or we can take the average of all the pricing, and that is how we can price our product. So this is just the two options that he has in mind, but he wants the analyst to analyze all these options and come up with a very optimal pricing model. The analyst then tries to understand what kind of data we will need, right? And she identifies that if we have the washing machine sales data for last couple of years, then we can use that to come up with an optimal pricing model, right? So again, let's recall the flow here. It started with a very simple business problem that we need to decide on the pricing model for the co-branded platform. Then it went from there to understanding what kind of data we have and why we need to launch a co-branded washing machine, because it leads to higher profit. The manager then quantifies what we are looking for, and that quantification is basically maximum profit. The analyst is trying to understand what kind of data is available and how she can access it. So when she gets the data, she can analyze the data and come up with results. She's looking at the first option, which is pricing the washing machine at the minimum of the product range, which is 7,000. So she does the analysis on the price versus demand graph, and she comes up with this curve. Let's try to understand this curve. So she says that as the prices, so the price is on the y-axis and the demand is on the x-axis. When at the highest price, which is on the top, we see that the demand is negligible. Almost no one is buying it because no one can afford it. And then we see that, as the price is going down, the quantity of the sales is also increasing, right? Which is obviously intuitive. As the price will go down, more and more people will be able to afford it, and hence the sales will keep on increasing. But then we see a threshold or an inflex point below which, if we reduce the price, the sales also reduces. Now this is counterintuitive, right? You are reducing the sales, but the demand is also reducing. Not many people want to buy it. So this is the outcome from the data. She further analyzes it that, what might be the reason for this. And then she explains that, below a certain point of the price, people perceive it as, low quality, non-luxury kind of product. And then they want to stay away from it, right? So as we reduce the price, obviously the demand increases, but below a certain point, the customers tend to stay away from it because they don't trust the quality of the product, or they don't trust the luxuriness of the product. So two things to understand here, right? First is the analyst comes up with the numbers or with the analysis of how the pricing is looking by the demand, right? Since it is a little counterintuitive, she also did some research and understands why this is happening, right? And then the result looks understanding, and hence we can now present this result. The next option was to price the washing machine at an average of all the washing machines. She says that, although that option is better than the minimum pricing, there's a better option that we can come up with, right? So try to understand what we have been doing till now. We were comparing price with the sales of the data, right? But that is not something that we want to do, right? We want to compare the price with the profit of the data, because ultimately we want to achieve maximum profit, right? So the right way to analyze is if we can see how the profit is ranging along with price. So let's see at this graph. On the top, we have our same old price versus quantity graph. So as the price reduces, the quantity increases. At the bottom, we have our graph for profit, right? So you see, as the price reduces, the number of quantity sales increases, and that increase in sales is able to overcompensate over the decrease in price, right? Let's understand it again. The sales is increasing, the price is decreasing, right? The increase in sales is able to overcompensate for the decrease in price, and hence the overall profit is increasing, right? Beyond a certain threshold or an inflex point, the increase in sales is not able to overcompensate the reduction in price, but rather reduction in price is overcompensating the increase in sales, and hence the overall profit is reducing, right? So this is the most optimal pricing for the washing machine, where we can achieve the maximum profit, right? This is not the highest price or the lowest price, and the sales is also not the highest and the lowest. It is just the optimal pricing and the optimal sales, a combination of which is giving us the highest profit, right? So she does all the analysis and presents it to their manager, and then the manager obviously appreciates it and says that the analysis has helped us eliminate the personal biases or the personal intuitions, right? The personal intuitions or the biases can say something else, but when we do the analysis and come up with results, it eliminates all those personal biases and the decisions can be taken which are backed by solid data analysis. Now that we have seen few examples, let us now try to understand the definition of data analysis, right? So going by the dictionary definition, data analysis is a process of inspecting, cleansing, transforming, and modeling data with the goal of discovering useful information, informing conclusions, and supporting decision making. Right? Let's try to relate this with the examples that we have studied till now. First, we have to do the inspecting part, which is basically understanding the data, understanding the business problem statement. Right? Once we get the data, we have to do the cleansing part. We cannot always use the data as it is. There are some certain steps of data cleaning that we will have to do. We will learn about that a little later. The third is transforming and modeling of the data. Again, the data that we will get, we cannot derive the insights from it as it is. We have to do some transformations and aggregations to get the data in a format where we can derive some insights. Right? So that comprises the transforming and modeling of the data. What do we get out of it? We get some useful information out of the data that will help us solve the purpose for which we were doing the data analysis. After getting that information, we have to inform the conclusions, right? We have to give the presentations, we have to inform the stakeholders that this is the conclusion that we got from the data analysis. And we have to support the decision making, right? So whatever business analysis or whatever business problem we were trying to solve, the data analysis will support the decisions required to solve those business problems. The 5 steps broadly classified is basically define why we need the data analysis. So there has to be a business problem statement and we need to understand how data analysis can solve that. We need to collect the data if it is not already available. We need to clean through the unnecessary data. The data as it is cannot always be used. So there are some certain cleaning steps that we have to do. Then we do the data analysis and then we interpret the results and then we apply them appropriately to solve the business problem. Let's now see how data is collected. We understand that access to good quality and rich data is very important for good data analysis. But many of us might wonder how these data are collected. Try to understand that with advancement into digitization of services of our day-to-day life, data collection is becoming more and more convenient and it is increasing day by day. Every online and digital activity that we do in our day-to-day life generate tons of data. Let's see a few examples. Any online transaction and shopping that we do generates a lot of data about shopping behavior, preferences, budgets, demands, and a lot more. In recent times, medical data is growing a lot because every medical activity that we do is getting digitized. Something like hospital visits, medicine purchases, home tests and home deliveries of medicines. These all generate a lot of data which are then used to maybe study the effectiveness of the medicines. It can be used to gauge the medical requirements of a particular area, and it is also used for marketing strategies and targeting by the pharmaceutical companies. We consume a lot of OTT content these days, both audio and video. A lot of data get collected by these, which are then used for content recommendation. Lots of analysis happens in sports area also. In fact, there's a complete movie around it. Do check it out. It's Moneyball. So lots of sports strategies are decided based on analysis of fields, player positions, player performance, team compositions, etc. Food industry is also a very big industry for data analysis. Everything ranging from menu designing, pricing, preferences, etc. These are all important part of decision making in the food industry. In fact, Swiggy and Zomato have so much data about their customers that they own multiple self-owned kitchens because they know that at what point in one region, what do customers prefer at what price. Commute data is also collected from apps like Google Maps, which are then used to optimize the route recommendation, improve the overall map experience. Different people see different recommendations on Google Maps because Google Map analyzes each and everyone's data separately and sends them customized recommendations. Before ending, let's understand what is data cleaning. So once you get the data, you cannot start using it as it is. There are many quality checks and transformations that we need to do before using it. Something like data standardization and normalization. We need to see that if all the records of a particular column are in a standard format. Something like date. Some records can have dates in different formats, year, month, date, and some records can have dates in different format, maybe date, month, year, right? So we need to make sure that everything in a standard format. If there are numbers, then we need to make sure that everything is numbers, because it might happen that few records are numbers, few records are texts, few records are comma separated. So we need to make sure that everything is in a standard format. In quality check, we just check that, if the data quality is fine, if there are any missing values or null values, if the numbers are making sense. Something like age, we know that it usually varies between 0 to 100. So if there are a lot of numbers which are above 100, or there are numbers like 150, 200, 250, we know that is wrong, right? So we need to check those data, and then we need to make sure that, those errors are removed. Something like date also. Some software, what it does is it replaces the missing values of the dates with standard dates like 1900, 0101. So you won't find blank values, but then you need to see that if there are some standard date formats, then those are basically blanks. Duplicate check. Sometimes there can be duplicates in the data which can hamper data analysis. So after all these data checks and making sure that data is of a good quality, we start data analysis.